what we're going to do is we're going to look at hydrates. Because just like we've been calculating empirical molecular formula and percent compositions for compounds, we can also do the same thing for hydrates. Now, just a reminder, hydrates are substances that have water molecules that precipitate out with our salts. So for example, our copper 2 sulfate pentahydrate, for every copper 2 sulfate formula unit, 5 water molecules would adhere to it into the crystal. And so because of this, we can therefore look at the relationship between the salt and the water. For example, what if we ask, what is the percent composition of water in a sodium sulfite heptahydrate? Well, since we have a molecular formula, we could say, therefore, hey, if we know our mass of water in 1 mole of sodium sulfite heptahydrate, and we know our molar mass of sodium sulfite heptahydrate, then I could determine what percentage of that total mass is due to water. So we could determine our molar mass of our sodium sulfite heptahydrate. And what I want to point out is that when we have our 7 waters here, that means that it's 7 times the molar mass of water, which we have here. We have 7 moles of water. Water has a molar mass of 18.02 grams per mole, so it's 7 times the molar mass of water. So it would be the molar mass of this compound plus 7 times the molar mass of water. And that's how we get this molar mass. Okay? And then we can get our molar mass of water. Now I just wrote it down here because we did the calculation right there. And then now, if we want to know our percent of water, we would just take the mass of water and divide it by the molar mass of the compound. So we get our percent of water. And so we see that water is 50.2%. Well, just like when we had we're looking at percent composition and we determined our molecular or empirical formula from the percents, we could also determine the number of water molecules that precipitates out with our salts by using a similar concept that we did before. So for example, if I had a cobalt 2 chloride hydrated solution here, and we can see in this example, in this case it has a red color. If I were to take that and heat it in a Bunsen burner or some other way, and I were to heat it to a temperature near the boiling point of water, what this would allow me to do is this would allow me to evaporate off the water. And if we evaporated off the water, then I would be left with the anhydrous salt. And so what I could do is I could look at the difference between the mass of the cobalt 2 chloride hydrated salt and the anhydrous cobalt 2 chloride to get my mass of water. And so then I could determine a mole ratio between my moles of water and my moles of anhydrous salt. So let's take a look at an example. So here we have a 5-gram sample of cobalt 2 chloride hydrate that is heated, and after it's heated, 2.728 grams of the anhydrous cobalt 2 chloride are left behind. So we know that we need to get a mole relationship between my moles of water and my moles of my anhydrous salt. So to do this, what we have to do is we have to first get our mass of our anhydrous salt and then convert that to moles. And we do that by multiplying it by the inverse of the molar mass. And then I have to get my mass of water and convert that to moles of water. And then I can do my mole ratio. Well, we're told our mass, in this case of our anhydrous salt, directly, because it's the mass that's left over after the hydrated salt was heated. The difference in the two masses is the water. So therefore we're left with 2.728 grams of cobalt 2 chloride. Okay, so we can take our mass of our cobalt 2 chloride and multiply it by the inverse of the molar mass, and this will tell us how many moles of cobalt 2 chloride are left after the sample was heated. Okay, then the next thing we have to do is determine our mass of water first. Well, that would be the mass of the hydrated minus the mass of the anhydrated, because the difference in the two masses is the water that was driven off through the heating process. So therefore, we can get our mass of water, and then we want to convert that into moles of water. And again, we know how to convert mass into moles. We should be very good at that by now. All we do is multiply by the inverse of the molar mass. So now, I know my moles of both my anhydrous salt and my moles of my water. So I'll just plug it into my relationship, and I see that I have a value of X. So what that tells me is that for every 1 cobalt 2 chloride that crystallizes out, 6 water molecules crystallize with it. So this would be my formula for my hydrate.